So my name is John Oskin, Senior Vice President with SmartSites. I will be your presenter for today's discussion. Um, SmartSites, as you know, has a portfolio of products now, all designed to drive digital transformations. Today's discussion is going to focus on one of these and a product called Able. But to tee up that discussion around what Able does and how it can benefit your organizations, I want to talk about what is good data collection and what is great data collection. So to start that discussion, I want to start with a couple of key bullet points here. One is the problems with manual data collection. So if you're doing manual data collection today on a clipboard, there's much better ways to do that. There are also problems with PLC coded data collection. We'll talk about that. We'll talk about why advanced data collection is needed beyond the bottleneck. So a lot of MES deployments, OEE deployments tend to focus on bottleneck level data collection. And we're going to talk about unit op level data collection. We're going to talk about data validation and the issues, both time consumption and also just issues associated with the data validation process. We'll talk about a concept called fault learning, which is a better approach for capturing machine faults. And then we'll talk about some of the unique data collection needs for MES and OE projects. And then finally, kind of that intersection between alarm and event data and how it can provide additional insights. So let's start with manual data collection. So what are the issues with manual data collection? So in high volume industries, and I'm thinking food and beverage, CPG, automotive, those kinds of industries, about 40% of the downtime is less than 10 minutes. So it's 1 minute, 2 minute, 3 minute kind of interruptions. If you're doing manual data collection, you're missing all of that. A good statistic is that in a food and beverage or a CPG plant, a typical production line will stop 20,000 times a year. Think about that. It's an enormous number of events. And again, that can't be effectively captured manually. It necessitates automatic data collection. Also, having operators capture downtime reasons is also not good data collection. So they're not accurate. They tend to select a reason and then they get back to work. So it's not always necessarily the right reason. If they don't have line of sight, so they're sitting at one end of the line, downtime is occurring at the other end of the line, they may not actually know which piece of equipment caused the line to go down. And so they guess, a lot of times it's wrong. And then for recurring issues, typically they're just not diligent enough to properly even tag or identify downtime. So another issue with data collection is with PLC coded data collection. So and what you find there is that you get inconsistency from programmer to programmer. So if you get a good programmer, then the data collection works. You get a bad programmer, typically doesn't. Even if you could get a good programmer, that person leaves, and a lot of times the knowledge leaves with that. Also, if you are writing ladder logic for your data collection, a lot of companies will implement data concentrators. So that adds cost and complexity, and then even more programming. If you're in a regulated industry and you have to write ladder code for data collection, that can involve revalidation of the process. In that industry, revalidate in a regulated process can take anywhere from $500,000 to $1 million to revalidate. So it's expensive and it's also time consuming. And then finally, even if you get that all right, when things change, you upgrade a PLC, you do some other kind of upgrade, that could break the logic. And so then that has to go in and get, corrected, if you will. The other point is around advanced data collection is really needed beyond the bottleneck. There was a time in the industry when doing data collection at a bottleneck point was adequate. And it's really not any longer. For long lines, it's difficult to capture the root cause if operators can't see the issues. Secondary assets are costly, even if they don't impact the bottleneck point. When they go down, uh, the relationship between assets really needs to be understood to properly account for root cause analysis. You can't do that when you're just doing bottleneck kind of reporting. Parallel operations, such as, I have a filler going into a bank of labelers, and then it comes back to a case packer. So those labelers that represent parallel operations can also pose data collection challenges, because if one labeler goes down, the line may not be down, but it's probably running slow. So how do you capture that? How do you understand the impact of that? And then you have operations that decouple the line, things like long conveyors, cooling tunnels. So when you're doing data collection and you have that type of equipment and you're trying to do root cause analysis, if you don't do it properly, that kind of equipment can give a false representation of the downtime. And then data validation. So kind of mediocre data collection usually means mediocre data validation. So here's the traditional way of doing data validation. Typically, you put an engineer on a production line, you wait for it to stop, then the engineer looks to see what's on the HMI, they compare that to what's in the MES or the OE system. Is it right? Is it wrong? If it's not right, you got to go in and make a modification, rinse and repeat. So this is the cycle of data validation. So on a typical food and beverage or a CPG line, that can be anywhere from 2 to 4 weeks per line. There's a better way to think about that. So how do you go from taking data collection from average, mediocre, to something that's really great? So this is kind of where some of the SmartSites technologies comes into play. So I'm going to start with the fact that great data collection can feed level 3 through 5 systems. So in doing so, if you do the data collection with a piece of technology called Able, that is a SmartSite solution, it can feed directly into SCADA, into MES, or the ERP layer. And with that, you have multiple options for collapsing the stack, if you will. Also, great data collection is agnostic to systems. So regardless of what kind of system you have in place for MES or OEE, think of Able as a data pump. It is a best-in-class data pump for feeding these other systems. It's a low-code, no-code application. It really provides richer data, as you'll see when I get into a little bit of a demo portion here. So what is Able? So what Able does is it takes machine, state, and fault information, and it couples it up with line flow. That's a key point. So it's not just going into a PLC, looking at a tag for identifying a fault or a downtime event. What we're doing is, by coupling up with line flow, we know the relationship of the adjacent assets. So again, think of a production line, filler, cartoner, case packer, and kind of knowing what becomes before the filler, knowing what comes after the case packer, and knowing what's, everything in between, if you will, is where Able really shines to identify root cause. We can bring conveyance and count information into that picture to fill it out. Able also is a cloud-based solution. It can be installed on premise, but natively it's cloud. And with that, we have an enterprise configuration application that if you or your clients have multiple plants, you can copy configurations from line to line and plant to plant. That makes the deployment go much quicker. There's live graphics that are used for diagnostics. So there's really good data validation tools that I'll show you that can, again, accelerate the deployment of data collection for your projects. Great data collection also collects data across all assets. So again, it's going beyond the bottleneck. And if you do that, you're getting 5 to 10 times richer data than you would if you're doing kind of line level data collection. Also getting 100% of the downtime, minor stops, major stops, everything captured. And so, so really good data collection has that level of detail to it. Great data collection also has an approach that doesn't require PLC programming. So with the Able technology, we have a configuration app. It's a drag and drop app for configuring all this. It models line flow, and then in doing so, it really supports a PLC standardization strategy. So it simplifies the data collection and takes it outside of the PLC. PLCs were originally designed to control machines, not collect data. So by decoupling the data collection needs from the machine control needs, you make for a much more effective architecture. Great data collection also includes a concept called fault learning. And with what fault learning does is uh, with Able, you don't need to go in and configure every fault on a machine. What we do is you configure the repetitive faults. And so a machine that might throw 100 faults, of those 100 faults that it might have the capability of throwing, probably only 10 or 15 of those are occurring on a regular basis. Those are the ones to focus on from a configuration standpoint. And then when fault learning is in place and it stays on 3 months, 6 months, 9 months down the road, what was a one-off fault, if it becomes a repetitive fault, then that's the time that it gets configured. So if you look at, this slide here, if you look at this, these ones at the bottom, movement monitoring function, P malfunction P sensor, that happened one time. So, you probably wouldn't worry about configuring that initially. However, these ones at the stop here, or ones at the top here, are the ones that you would. So, machine stops, product incorrectly positioned, anything that's in kind of this yellow or red zone is what gets configured. And if you do that, you can reduce the engineering time by up to 70% by focusing on the repetitive events. Also, along with data validation, Able has a digital twin component. So we have a record structure where we are capturing every single minute of uptime and downtime in the form of a database record that then can be replayed, almost like your DVR, where you can fast forward, pause, and rewind through the data. Very powerful. And then lastly, Able can collect data on speed loss. So when an OE calculation, performance is really the component, the KPI that focuses on speed loss. Speed loss is the inverse of performance. So if performance is 95%, your speed loss is 5%, if you will. But most systems really just think of that as a number, okay? What Able's able to do is break that down. It can take that 5% and it can show you how that breaks down into set point changes, maybe ramp up and ramp down intervals. A lot of times the line control systems itself can speed up and slow down the line for its associated behavior. You'll be able to see what the impact of that is. Is that giving me a 3% additional speed loss hit on my performance number or a 5%? So you can Pareto this out just like you would downtime. And with that, let me just kind of take you through what great data collection looks like with the actual software here. So this is the configuration environment. It's a drag and drop kind of environment. And literally the process starts with just taking assets, dragging them onto this canvas, and then starting to connect things up. So when I do that, it gives me a prompt here and asks me if I want to add root cause. And I'm going to say yes. And so in doing so, what I've done is I have bound those two assets together. So it knows that these two molders are feeding into this press operation. And that's an important concept because when you get to a connected production line and downtime starts to propagate through that line, kind of knowing the relationship of these assets is important for root cause analysis. If I go in and I click on an asset, you get details that you fill in around, like what PLC am I in? What type of an asset is it? We have 4 types of assets. We have line assets, we have cell assets, which are unit operations, secondary assets, which are feeding operations into those unit operations, and then virtual assets. So a good use case for a virtual asset is If I have a bank of labelers, I might want to look at each labeler individually, but then I also might want to look at it collectively. So that collective analysis comes from creating a virtual asset. There's items that I get defined that it's just a fill in the blank from a template around things like run state signals, alarm bits, and alarm matrices, and then finally conditions. Conditions are the kind of the meat of it. So we use a 4-state logic engine. So a machine is either classified as either running, it's down, which means it's faulted, it's starved, or it's blocked. You can have multiple blockage states, you can have multiple starvation states. Typically, you're going to have many faulted states. And so this is kind of where the state configuration is generated from. Once all this gets configured, kind of goes into a runtime mode. And this is what it looks like in runtime. So in runtime here, what I've got on screen here is just a typical factory. So, and I can, if I have a very large factory, we can build this out as large as it needs to go. I can also break the factory up. So if I am a molding area manager, all I care about is my molding operations, boom, I can create a view for that. I'm an assembly area manager, all I care about is assembly, here are my assembly operations. And then, finally, if I want to look at the overall factory, I can kind of create a view for that. So by being able to build out a factory view as large as it needs to go, or to break it up into multiple views, you can accommodate just about any kind of factory size you'd have out there. So the first thing you're seeing on screen here is just real-time visualization of what's running and what's not. Green means the machine's running. Here, red means that it's down. Orange means it's blocked, and then yellow means it's starved. So you get immediate view as to what's happening. I can also click in and take a look at some details here. So if I wanted to click on one of these machines, it's going to give me kind of a view here that's kind of showing me categories of downtime associated with that asset. The raw data looks like this. So you can kind of see we are toggling between uptime and downtime. We're running, we're stopped, running, stopped. And if we're stopped, why are we stopped? Low fill, stuck cavity, so on and so forth. So I can get down to the root cause reason as to what's happening for a given asset. It gets really interesting when we start talking about connected production lines. So we're going to talk about this packaging line here. So if I go into the assembly area and I look at that operation, and now I bring up what's called the DNA view. The DNA view is a Gantt chart representation of that line. So I have the line at the bottom, line 1. I have all these unit operations. So operation 10, operation 20, 30, and 40. Those are the ones that make up the line, if you will. So with this DNA view, what you can see here is the sequence of downtime and how things start to ensue. So you can see when something happens here, how it sort of cascades through the line. And then Able has really good tools to help understand the data and assist with data validation. If I click on the root events button here, what it's going to do is it grays out everything that does not have root cause association. So the things that pop in color do. So now if I click on one of these guys here, you can see where I have this sequence of 5 events, but it's really one event. It's all initiated by Op40. Op40 started the downtime. It cascaded through the line, eventually took the line down. So these events really are one event related to the root cause here, in this case being Op40. Other things that you can do here, and this is again comes for is very helpful for data validation, is being able to look at production sequences. So I can pick a different time frame. In this case, we'll just keep it on the current time. But I could go back in time if I wanted to look at, say, yesterday at this time, and I apply that filter here. The Gantt chart looks the same, but I picked up a historical time frame. And now if I click on this replay button, what it's going to do here is it's going to combine the line flow view at the top along with this Gantt chart view. I can make this bigger to make it a little bit easier to see. I can drag this split screen view up and down, And now if I click on the play button, it's literally replaying yesterday from 10:20 to 11:20. I can fast forward it, I can pause it, or I can slow walk it. So you can see as I slow walk it here, I can get to a point of interest. So maybe this was around 10:30 when something happened here. So if you see here, you can see that op 40 went down, cascaded into op 30, op 20, and then when op 10 went down, now the entire line is down. This oval asset is the one that's monitoring the entire line. It's the one that picked up the root cause. It's identified that op 40 was the root cause. And not only that, but there was a discharge issue. So it pulls the actual fault tag from op 40 to identify the reason you were down. So this is a digital twin concept where it allows you to replay this data, but extremely valuable for data validation. Because what can happen is if you or a systems integrator that you're working with is implementing Able and something doesn't quite look right with the data, all you got to do is just click on the share button and click on the mail link. And what it's going to do is it's going to create an email here. It's going to tell you that it's going to pick up the time frame that was analyzed. And then it gives you this hyperlink here that if somebody gets that hyperlink, it's going to take them straight to this time period where the data was being questioned, that then it can be analyzed further. So the result of all this is that rather than having engineers parked on a production line waiting for things to happen to validate the data collection system, what you can do with Able is do 90% of this remotely. You can have someone, looking at this data remotely, making adjustments remotely, and then really you might just have someone on site for that, that last mile, that last bit of data validation as it's needed. So a lot of powerful things that we can do that. There are other things that Able can do for the shop floor. So if I go back to that factory view, I can create heat maps of this kind of a view here for KPIs like availability, mean time between failure, mean time to repair, or even rate information. So if I start with availability, it's going to show me a heat map of availability. You can see everything's in green. I've got this one molder in orange, and then this press one is in red. So it's the low performer. It's set such that if it's less than 80, it's going to be in red. If it's 99, it's going to be green. Anything else, it's going to be somewhere in between. So this is a bit of a hot spot, at least for the day. If I go to mean time between failure, you can see now we have more assets in yellow. But then if I go to mean time to repair, everything's back in green, which at least when the machines go down, they're getting back up and running quickly. So with these three KPIs here, you have a quick assessment of where the hot spots are in the factory going to be that day. In this case, I'd probably be focusing on press one as a hotspot point. We can also do the same thing with rate data. So it's very important on high volume production lines to kind of maintain line speed. And so with having a rate-based heat map, you can kind of see which machines, which stations, which areas of the factory are running slower than their design speeds. So now you know what great data collection looks like. Let's talk a little bit about some other unique elements specifically for MES. So most MES systems focus on line level data collection. If you introduce Able as the data pump to feed MES, now you can take data collection down to the unit op level. For OEE projects, 90% of the OEE projects that we see do not capture performance beyond what I originally described. So they're really not breaking down speed loss. They also do a great job with single point data collection. So now you have the ability, if you're currently have an OE system in place, where you can now add unit op level data collection into that picture. And then from an AI and an ML perspective, Able is a very effective data pump for providing really rich unit op level data to feed AI and ML models. Everything from state data to MTBF, MTTR, and rate kind of information. Other systems typically don't consider line flow. So now you have the ability to provide prescriptive and predictive information for modeling. And then our data streams are optimized for AI ingestion. So if you're interested in that topic, we can certainly have one of our engineers follow up with you on that. But with as much as 4 to 6 weeks of data, you can start building out an AI ML model off of Able data. So to kind of summarize, data collection is not a checkbox for, do you have it or don't you have it? It's really the difference between what is good data collection and what is better or great data collection. So as you think about your data collection needs, my guess is that if you have systems in place today, they are doing some of this, but probably not all of this. You're probably not collecting beyond the bottleneck. And if you do, it probably is going to require additional programming. You probably don't have a concept like fault learning. You may not really be doing root cause analysis. You may be doing data collection on a machine center, but not really reconciling it with what's happening either upstream or downstream. You may have data concentrators in place or have projects where you're trying to put in data concentrators, and that's just not necessary. And then as we talked about, the advanced ways of capturing speed loss is another functionality that most data collection technologies don't really think about. So as you think about utilizing Able in your digital transformation initiatives, it's a nice complement to what you already have in place. It's not going to replace your MES or your OE system. It's going to add to it. Again, think of it as the data pump, a better data pump to make those systems work better. And if you do that, you're going to get a 70% reduction in engineering time for data collection for a project. You're going to get 5x improvement in data fidelity because now you're at a unit op level as opposed to line level. We can collapse deployment by anywhere from 4 to 6 weeks per site from a data collection perspective. And then with this, you're getting enhanced functionality, you're expanding the digital footprint for these kinds of projects. So with that, you now know what great data collection looks like. And we encourage you to contact your representative today if you'd like more follow-up. With the time we have available, we might be able to field some questions that people have. If you want, you can unmute your mic, or David, if you're on, you can field questions for me in terms of what questions people might have. All right. I've got a question that came in that says, how quickly can you deploy Able in a project? It's a good question. So one of the rules of thumb is that at least for like food and beverage and CPG production lines, Able can usually get stood up in a couple of weeks. So it usually takes about a half a day per asset to configure Able. So if you've got a line, with 10 or 15 machine centers, you're talking about a couple weeks of configuration time. So it's very rapid deployment. And then even from a data validation standpoint, a line can typically be validated in less than a week. Another question is, what kind of industries can this be used in? And so again, I think of high volume industries as for the root cause benefits of Able. So food and beverage, CPG, automotive, certainly. But then also if any kind of MES project where you're looking to just simplify and reduce the amount of time it takes to put data collection in there, even if it's a standalone asset. Abel's a good candidate, for whether it's a molding operation, stamping press, what have you. So. Okay, and with that, I think we are out of time. We will let everybody get on with their day. If you have any other questions, reach out. But thank you for your time and attention today.